Today we want to talk about rectifiers, and we using on this um, lecture we using the diodes, just bridge rectifiers. So when we talk about the rectifiers, is meaning that we want to change the AC waveform to DC waveform, and the component that we have is diode. So we can also use the thyristors, IGBTs, but today we want to use the simple one is diode. So normally when we use the diode, when we have the AC waveform, in the secondary of the diode, we will have only positive side of that. So negative side will be removed. So if we want to simulate this one, go to the SimScap, electrical, and here a specialized power system. First, same as always, we put the power GUI and we're changing this simulation type to discrete and okay. And here we need one AC source. So source, here we have AC voltage source. Then we need a resistive load on passives. Here we have load, just Ctrl R, you can rotate it. Double click and change it to R. We can put, for example, 5 ohm for this. And this by default is 100 and frequency to 50, for example. Then we need measurements. For measurements, we can go to here, sensors and measurements, click, and we need current measurement, for example. We connect this one to here, and another current measurements to the resistor, so we can see the current from here and here. Connect these two to each other, and then we need a diode. So in power electronics, here we have the diode. Just put the diode here, connect like this. Okay, now we have the completed circuit, and we need one scope to see the outputs. Okay, and if you want to see outputs of these two sensors in one scope, just double click in the sensor in the scope. Here, from the configuration properties, change this number of inputs to 2, and okay. Then you will have 2 inputs, one before diode and one after diode, and change the subtime to 0.2 and click run. If you double click on the scope, here you can see the output of the diode. And the current in the input is also same because this current is go to this direction. So you can see the current in the primary and secondary of the diode is same. But if we put the voltage measurements, for example, here, if we put the voltage measurements here and one here, I click run again. You can see the voltage is different. So the yellow one is after diode, the blue one is before diode. So blue one is a complete AC with negative and positive, but the yellow one is only the positive one. So the current, because it's flowing from here and go, is same, but the voltage is changing. But the problem that we have here, if you see, is not DC current anymore or DC voltage. It's just go 0, go 0. So it's not DC. It's just half sinusoidal. If we want to have a better waveform, here we have another circuit. So here we have diode bridge. So if we locate the diodes like this, then we can make a rectifier or diode bridge. So for doing that, just say remove this and copy this and paste here. So we can have it as a base, and we don't need this also. Okay. So if you want to model this, we need 4 diodes. Just put like this and just connect this to here, this diode to here, these two to each other. So now you have this diode bridge, but the connection is of the source is important. It's going here, connected here. The negative should connect to here, and this one connect to here, and this one connect to here. So if we run the simulation again, you can see we have negative, the positive point, but negative is also reversed to here. So it's more like DC. If you want to compare these to each other, easily you can connect here, run again. So you can see this yellow one is for only one diode. The blue one is for the diode bridge. And yeah, here if you want to zoom, so we can see the blue one is go and back, but here the yellow one is 0 here. But the problem that we have here is not also DC. It's just some ripples, and it is not good for connecting to any devices. So we have another circuit, is exactly like the previous one, but we should add a capacitor here before load. The capacitor is storing the energy and charge and discharge, make this sinusoidal half wave to a more or less DC waveform. For simulating that, just again copy and paste the circuit that we had, and here we can connect to here to compare. So this is a circuit exactly same, but we need only one capacitor. If we connect a capacitor like this, then you can see the charge and discharges. So just changing to C, but the value, we don't know the value, just keep this. So it's charging and discharging during the ripples. And if we click OK, you can see it will be more or less same with the previous one. It's exactly same because we didn't change the parameter for this capacitor. So this is super small. If we increase that to 0.1 farad and click run again. So here you can see this blue one is a new DC current. This yellow one is for previous one. So we can see is more or less DC. We have some ripples, so it go from, I don't know, 18 to, we can see, it go from 19.4 to 19.6. So we have a small ripple here, but it's more or less DC. So this is a way to make an AC DC converter. So this is a converter that we have, and for sure there is more room for upgrades, but this is a simple one for AC-DC conversion.